BERT and beyond, and Evi comes from RISE. Yeah? Welcome.
Hello everyone, nice to be here. This is the second talk. Probably I will try to make it a bit shorter, so we can have some time for questions, or in case there are no questions, we can just enjoy your evening. So my name is Evangelia Gogoulou. I'm industrial PhD in RISE. I originally come from Greece, and I moved here 2 years ago. I did the master in KTH in machine learning. I did my master thesis in BERT, on BERT in RISE, together with the NLP group there. And my thesis was on BERT also, so this was the starting point for me. And then it felt sort of natural and quite challenging to continue my PhD. And today I'm going to talk about BERT, but more specifically, what happens when we try to train BERT on the Swedish language, and also what are the challenges there, and also what is the future of BERT, what comes after. But first, a little bit about RISE. For those who don't know, RISE stands for Research Institute of Sweden, is a leading innovation partner. We have various projects in different technological sectors. We collaborate with private companies, the public sector, and also academia. Personally, I'm a member of the Natural Language Processing Group. We're very much interested in NLP and AI problems, both from a research perspective, but also from the perspective of industrial applications. So the presentation outline for tonight, I'm going to start with presenting the basic BERT concepts. I'm going to keep it a bit short, since Gabriela gave a very good introduction on the BERT architecture. Then I'm going to talk about what comes after BERT and what is not, maybe. And last but not least, I'm going to talk about the Swedish language model. So let's start. So what is the language model today? Maybe we have seen this before. If not, it's quite frightening. It looks very frightening. So this is BERT in the middle. We have GPT and also another category, and all these different models that came after it. Quite fascinating. This happened almost 1.5 years ago, or like when BERT started. So all of these models, even though they have different training objectives, more or less transformer layers, or different pre-training data sets, all of them have some are based on the same core concepts. And this is what I'm going to talk about now. So the core ideas. Let's start from the smallest one, self-attention. So self-attention can be seen as a way to contribute to the presentation of a word, where all words in the input sentence can contribute, but this contribution is weighted. And this weight depends on how relevant is this word. So using self-attention, we build transformers. And this is a transformer coder and decoder architecture. One consists of self-attention layers and intervened with feed-forward layers. The usefulness of this architecture comes from the fact that it's a computational effective way of computing attention as some matrices computations without using any recurrent mechanism. That means that we can compute it very much faster. So what happens when we stack transformer layers one on the top of each other? No, it doesn't have that. And then we're going to talk about the training objective. So when you stack transformer layers, one on the top of each other, you need to train them. You need to find a training objective. And from my perspective and from our group perspective, the main contribution of BERT is this masked language modeling objective. So when you have this sentence here, robots are blank friends, according to the masked language modeling objective, this targeted word here will be predicted based on both the left and the right side context. So in this way, we achieve something that is called bidirectionality, which is the B in the name of BERT, by the way. while the traditional language models usually do left-to-right prediction. So they predict this blank based only on the words that came before or only the words that came after it. So then we move to another very important concept, which is called transfer learning. And I call it sequential here because in this method of transfer learning, we have two steps that one comes after the other. So in the first step, we have the language model, which usually consists of a number of transformer layers trained on a predefined training objective on big amount of corpuses, which are unsupervised, so we don't need any labels. Basically, these masked, removed words are labels. So after training these models for quite a long time on big GPU clusters, we produce a number of contextualized representations. We can then download them in our computer and use them in our fine-tuning application without having to retrain the whole model from scratch. So this transfer learning gives us the ability to use the powerness of the BERT embeddings to do classification tasks or question answer tasks or sentiment analysis. So this is quite innovative, and this is what changed the field. But what is the future of language models? Are there any cases that BERT doesn't perform so well? So the first one is inference, which is something also that Gabriela mentioned. So previous work has shown that BERT, even though performs very well in capturing seducting pictures and basically identifying words that appear in the previous document, have very poor inference capabilities. And I'm going to give an example of what is inference. So this is from a dataset called the HelloSwag. I'll have it very back in the slide down, the link. So this is a task of common sense inference where you have a short piece of text and you have 4 different answers. And this bold one is the one is the gold standard answer given by humans, and this is what the BERT model gave as an answer. So if you give it a read, you will see that the answer that BERT gave, it doesn't really make sense, because how can you smooth a stone using a knife? Even though the words that are used in the answer are relevant to the question, it doesn't really make sense to the human. So this is one of the problems that the research community has found with BERT, that it doesn't perform very well in reasoning tasks when you need to have some basic concept in your head when you answer a question, or when you predict the next word or sentence. Another interesting and very important aspect is biases. So the question here is, how does BERT associate the embeddings of gender or race-related words with specific attributes, for example, career-related words? And actually, previous work has shown evidence that different types of biases actually exist in BERT embeddings and GPT-2 embeddings, but still these biases are quite less comparing to word-to-vec models, which are the traditionally used language models. So this is a quite important aspect that I will also mention. That's also relevant to the Swedish language model that I will talk about later. But what about models not for the English language? So this is a link I found quite recently. So the NLP group in Milan has created this platform. You can access it. I have also the link down here, where they try to note down all the different models. These models are trained from scratch on different languages. So here they say that there are 18 different languages and 30 different BERT-based models. And also another interesting thing is that they try to measure the performance of different tasks comparing to the multilingual BERT. because BERT, apart from the English version, has also a multilingual version, which is basically for the pre-training phase. They have scraped the Wikipedia for a big number of different languages. So if you want to use BERT for an NLP application in another language other than English, it is an option. As well as XLMR is another very recent option that performs quite well on different languages. But still, it would be great if the monolingual model would outperform the multilingual one on a specific language, right? It should be, because it's trained on one language. So this is what we're going to do with the Swedish language model. So, but first, there have been first attempts, as you all know. So there have been published 2 models independently by Arbetsförmedlingen and Kungliga biblioteket. Which is a very nice initiative, since every one of you and every one of us can download the pre-trained model and use it in a possible application or just play around with it. But note that both of these models published mainly they reuse the original BERT architecture or some other BERT-based model, and they have just trained it from scratch on Swedish data, which of course is a very good way to start. But can we do something better? Well, probably yes, or this is what we believe in. So actually, we have recently started a project in RISE in collaboration with all these different partners, and Peltarion, one of them also. So the project is language modeling for Swedish authorities, where the goal is to build from scratch a Swedish language model tailored for the Swedish authorities, tailored for the public sector, and also produce different applications that are relevant to this field. And another thing, of course, is that we're going to publish this model, so you will be able to use it in your applications or play around. But of course, there are some challenges here that we have already identified and working on. So one of the challenges is that, as I said, this model is going to be trained and trained on Swedish public data. So of course, having bias-free text representations is a very big priority. And this bias can exist in 2 different ways. First, there can be some hidden biases in the data sets used for pre-training or for fine-tuning in the applications. And there also can be biases encoded by the language model itself, as I showed before in that slide. So this is something to talk about. Also, another interesting challenge is that can we perform better than state-of-the-art multilingual language models? Because as I said, we're going to train this model from scratch on Swedish data. So we should perform better than at least multilingual BERT. And last but not least, what is the minimum amount of training parameters needed? Because if you follow this field after BERT, you will see that all the architectures coming after, they stack more and more of transformer layers. And one example is this. So the number of BERT parameters is somewhere here. And then there is this model came from Microsoft a couple of weeks ago, which has 17 billion parameters. So in order to train this, you need an increasing amount of computational resources. So the question that we are asking is that, is it necessary to have all these parameters? Or maybe you can do some smart choices to reduce the number of parameters and still achieve state-of-the-art performance. And with this very nice question, I will close my presentation. Thank you very much. I also want to say, that we're looking for students who are interested in NLP. So if you are one of them, just come to talk to us. So any questions? I'm happy to discuss and answer.
If there is bias in the data, for example, gender or race, like you mentioned, how can you make a model which does not have the same bias?
Did everyone hear? Or could you repeat the question?
Repeat the question also for the video.
Summarize the question in the mail.
Okay, what you ask is if there is bias in the data, if you can ways to remove it, or yes. Okay, so of course there are some ways to anonymize the data in the first place, and then there are also some ways to debias the model when you train it. So there are different techniques that you can explore. But of course, this is quite a new aspect in the field, because it's quite recent that researchers started talking about bias and how can you make a debiased model. And even the methods used to identify biases in models are quite questioned, because the recent architectures, these transformer models, are quite different from what VEC used before. So yes, you can do it, but you need to experiment a lot, I guess. And yeah.
Did the models released before from Arbetsförmedlingen and Kungliga biblioteket, did they beat the multilingual from BERT?
So the question was if the models published by Kungliga biblioteket and Arbetsförmedlingen beat the multilingual BERT. Yes, I think so. Maybe I'm not correct because I haven't checked very recently, but I think so. Yeah. So this is a good baseline.
I'm wondering about the public or open data set you're planning to use. Are there like a lot of different data that you're using, or is it one particular platform that you're thinking about?
No, so the partners are. So there are many Swedish authorities. So a percentage of those are going to be data provided by them, and also IF Innovation for Sweden, where they have also different types of data. But of course, we are going to have a look on what is publicly available and, of course, appropriate for this model, because, as I said, bias is very important. We want to have it bias-free for sure.
Thank you.
All right. Do you have a time plan for this project?
It's 3 years.
3 years.
Yes. But the plan is to have some first model ready by the summer, I would say. So.
Awesome. Thank you.
So what are the downstream tuning tasks for such a model in Swedish?
Well, I wouldn't say that they differ from many other tasks, because if you take an NLP task, it comes down to some sort of classification. So, for example, email classification, it could be your name entity recognition, or question answering, where you have some piece of text and then you ask a question that is referring to this piece of text you have seen before.
Yeah. And what kind of benchmarks do we have in Sweden for those tasks?
Actually, we don't, and we're discussing of building something like GLUE, if you have heard, GLUE benchmark for Swedish, because this is also a problem since this haven't done before. It's quite hard to know if you are right or not, or where you're wrong.
Yeah. Yeah. What about the tests done by students, like this Nationella provet, or there you have reading comprehension? Couldn't that be used to train the model?
Could you?
Yes. So the question is if you can use the data sets from the Nationella provet. You mean if I'm correct, it's the exams to go to university, or?
Yeah.
Okay. Yes, I guess that could be used. I'm not aware that if we have access to them right now, or how hard it is to get access to those tests, but this could be an option. Yeah.
Does the public sector, those that are in the public sector that work with you, do they know what kind of tasks they want to use this for?
There have been some discussions, but we haven't finalized the list of the tasks. But as I said, it's more or less the tasks you can have in every company or in every other industrial application, or you have seen in this GLUE benchmark, or there is some list of sentiment analysis or name entity recognition, sentence classification. It all comes down to this list of tasks. first.
Will the models be open sourced, or are they just for Swedish?
Yes, of course, they will be open sourced. Of course.
Along the way, or just when the project is done?
I guess when the project is done, or we will see how this will be done. Yeah.
What are the challenges with Swedish compared to other languages?
What are the challenges of Swedish comparing to other languages, you said? Well, Swedish belongs to this set of Germanic languages, so you still have this white space, for example, comparing to other non-European languages. But actually, this tokenization level is something that we want to look at, because it's something that usually has been seen as default. There's this word piece or byte pair encoding that you use, but we want to look on designing a tokenization level specifically that's more related to the Swedish language. Yeah.
Is there any Norwegian and Danish are somewhat similar to Swedish? Is some approach to do a joint thing with Norwegian and Danish, and maybe yeah, to use the same resources there, or maybe?
I'm not aware of any concrete. Yes, sorry. So the question was if there are some plans for using Norwegian data or Danish data. I'm not aware of these choices, but of course it's something to consider, since the languages are quite similar. And I guess also could be fun to do something called zero-shot learning, where, for example, you train the model in Swedish, and then the fine-tuning task you have Danish or Norwegian, which are quite similar. So hopefully it will perform quite well.
Are you also generally training models on real text, usually when you have I don't know, reviews or something, then people tend to write more informal and also with a lot of spelling mistakes, but usually those models are trained on correctly spelled texts, so they're not really applicable then to when you have actually text written by users where you have a lot of words which would then be unknown from the vocabulary. Do you work on something there?
So the question is, if for the pre-training we're going to use text written by people where this text can contain some spelling mistakes or some grammatical errors. We are still in discussion for this, but I'm not sure if we're going to use this sort of text, because of course it depends on the partners of what they are able to provide. Because since all this data belongs to public sectors, there are all these security measures, so we need to fine-tune a pipeline for having access to this, and of course ensuring the security of the whole process. So, yeah.
Is there any interest in either developing a model for certain specific domains like healthcare or law or something like that?
Yes. So the question was if there is interest to train a model on other domains like healthcare or the law domain. I would guess that for some specific applications, fine-tuning this model on healthcare domain data, specific data, it could be good enough to have some good performance in fine-tuning task. About the law domain, I'm not really sure, because also the language there is quite specific. Yeah.
Okay.
Thank you very much.